Let me know once you can see my screen. Can you see my screen?
Yeah, Anish, your screen is visible now.
Right. So thanks everyone for joining on this weekend, and I really appreciate you spending your weekend time to learn something new, and hopefully get something new to learn here from these sessions and carry forward it to your professional engagements. So, without much further ado, I'll introduce. Basically, today we'll be talking about the generative AI, a very brief introduction of generative AI, and then we'll have a short demo of how do you actually optimize the stable diffusion model with the Intel One API, right? And before I go ahead, there's some short notices and disclaimer. And let me go to the introduction to. I'll introduce myself. So, as the speakers introduced me, I'm actually the AI software engineering manager for Intel and I handle all the customers from the APAC region. And as part of my responsibilities, I actually engage with customers and developers like you to evangelize the Intel One API software tools, right? And we also closely work with customers engineering team to help they develop the AI some solutions that they might have. The AI solutions that they have might be at the very ideation stage, or might be at the POC stage, or maybe even at the say production stage. So we closely, the Intel's engineering team and the customers engineering team closely work together and see how do we actually optimize the solutions to gain better performance. And as part of all those things, I engage in workshops, trainings, and tech talks like this to bring the knowledge of Intel One API to the larger audience. And the eventual goal is to bring the AI everywhere to everyone, right? Everyone should be able to use AI. That's the overall goal. And I'm available on Twitter and LinkedIn. The links are passed here. Do connect me over there, and we can continue the conversation there. And let me go to the next one. Yeah. So I will not talk about the technical aspects of generative AI. Probably most of you are already aware of all the technical aspects. What generative AI is, I don't have to tell what generative AI is, and what are the different options available. But before we actually go ahead and discuss the other aspects of generative AI, one of the common uh, discussions that we see, or the common news that is being flashed, or probably what you have been constantly be hearing is with the advent of generative AI, there might be potential job loss, or there might be potential jobs that might be replaced or taken over by completely by AI. One classical example that I can give is there's one popular photo editing software tool creator, a company. It's a huge company, and they have around 43,000 employees, right? And when you compare those that companies with the Midjourney is a generative AI company which has pretty good AI models that can actually generate images out of your text prompts, right? And they have only 11 employees. And when you compare these two scenarios and the news that you constantly hear in the market, what you feel that we developers might have a feel of a feeling that eventually all this the creative work might be like writing some text, right? Be it poetry, or somebody writing a lyrics, or somebody writing a contract document, or all this are creative works, right? And then maybe there might be an artist who's actually creating all the artistic things. Or there might be a musician like A.R. Rahman, or other musicians who are actually creating music. Or there might be uh, cinematographers, directors, and all creating all nice videos and all the things. But what with the advent of generative AI, what happens is generative AI is actually will be able to do all this kind of creative work that we have been seeing. And maybe like my personal assumption, personal take is, going forward, a lot of this kind of a creative work which involves generation of text, generation of image, generation of audio, that includes music, generation of video, will be taken over by AI, specifically generative AI by generative AI. but that doesn't necessarily mean all these raw jobs or the creative jobs are kind of becomes irrelevant. What I feel is all these creative jobs will be the generative AI will give you more increased focus for the humans to give better value for the whatever work they do. Earlier, if somebody is taking, say, if I had to generate a legal contract document for one particular transaction, maybe usually it takes 2 3 days for us to generate all these documents, review it multiple times, get it vetted against by others and things, right? But with the advent of generative AI, it doesn't mean that I'm totally eliminated as a guy who's actually generating a legal document. What the generative AI does is basically goes and helps you create the template or the at least the basic structure of that document. And we as humans, I can like it generates it in like say 5 seconds or 10 seconds maximum. Usually it takes multiple seconds to generate a document. And once the document is generated, I as a human, I can just go do and high level review and do small minor changes. So a work that usually was done in 2 days probably can be done in couple of hours. So what that benefits me is, like, I as an creative guy, probably I can use my extra time. So the instead of spending 16 hours on 2 days on a particular contract generation document, I spend 2 hours, and the balance 14 hours I could invest in other creative things. I can actually do more value additions to the work that I'm doing. And all this we are doing by taking the advantages of the technology, the platform and tools that are being developed on a day-to-day basis. We hear on a day-to-day basis new language models are being released. Google has its own set of language models. Then Facebook has come up with their own large language models like the Llama 1 and Llama 2. And then there are many open source models like the Stable Diffusion that we are going to discuss today, or the Open Journey, and many other models. And all these things basically will help us a lot. And that's we are in actually a very good time zone, time period, where we are actually seeing the transitions of machines helping us, helping we humans in a very positive way, helping us enhance our value additions that we do. And one more probably one more classical examples that I can give is there was one large financial institution that even before the coming up of ChatGPT and all the other craze, this financial institutions was having like around 16,000 financial advisors, basically giving various kinds of advice to all the different clients of their clients globally. And what they internally did was they took a large language model, and basically they were working closely with one of the currently existing large language model providers. And what they did was they fine-tuned that particular large language model with all the financial data that they had. Over these years, they would have had large amount of financial data and all these things. They collected all these things. They fine-tuned the large language model with that particular data that they had, and then they implemented guardrails and all these things. And then they took a set of 300 financial advisors and deployed this tool to them and asked them to use it and see how it goes. And what they saw was there was a tremendous improvement in the kind of financial advices they were able to give, and also the accuracy and the time to generate those kind of financial advisories were very fast. Instead of taking multiple weeks, it used to be half a day or less than that. And with that, this thing, what they did was they expanded the scope, and now they are actually planning to deploy it uh, entirely within their enterprises. What I'm all this trying means is now all the large enterprises will eventually start using different types of generative AI solutions. Uh, Say, for example, the big companies, big software companies might start using large language models like CodeGen. CodeGen is a large language model specifically for generating code and helping developers. And we already have multiple customers, or there's also a model called star coders. There are multiple customers working with this kind of large language model specifically targeted for developers, so developers like you and me, uh, and develop platforms that can help us write the code. What's the final advantage is, these large language models has data from all these years of work that all these many people have invested, and it is actually able to give you better solutions in a short period of time. And you as a as an experienced developer, you could actually go ahead and fine tune that, this review it and deploy your solutions faster and add more value to the final work that you are doing. So the world is going in this way. Going forward, there's be lot of generative AI use cases across, disrupting multiple industries, not only the software development, but it's going to help the other industries like the banking and finance, healthcare, manufacturing, and you name it, and probably almost all the industries. Definitely all industries will have some kind of a creative work being done. Creative work, it will be like text, image, audio, video, and all those things, right? Any industry will have some kind of this kind of a data being generated, and definitely AI, generative AI specifically, is going to disrupt all these markets. So with that thought, what I will encourage everyone is to learn all these new technologies, be ahead of this new technology, and try to master this, and help the set of new set of requirements that will be coming up your way, right? About more and more requirements will be coming into this kind of field. So learn this all these technologies and be aware of this, and be a master, be relevant in the industry. So with that, I'll just quickly see if there is any questions. Hopefully I'm audible and all things are good. Okay, looks like, yeah. I'll continue. And before I talk about the stable diffusion, I'll briefly like to introduce to you to Intel One API. So in One API is an open source, cross-platform, cross architecture solutions, basically helping you as AI developers, or probably people who are working on high performance computing, with optimized set of libraries and tools and libraries that will help you, not tied up to a specific architecture, right? There are hardware, competing software solutions that are specifically tied to specific hardware. But they, with the Intel One API, Intel One API is an open standard. It's not, again, Intel is actually contributing to One API, and there are many other companies who are actively actually contributing to One API. And Intel has taken up this One API standards and actually implemented those One API standards across multiple libraries. So even though we all know Intel as an hardware company, but Intel also actively works on multiple software tools. And here in this screen, you can see these are common tools that we as AI developers might be commonly using, like the TensorFlow, PyTorch, or NumPy, SkyPy, Number, Pandas, all those things. Uh, the advantages of using One API for your development is, you are not tied to a specific architecture. You can, if you're developing your solutions, AI solutions using One API, you have this guarantee that those solutions can run on a CPU, GPU, or any other accelerators of your choice, not only on the Intel but also on the competing hardware. So we encourage you to learn all these things. And for this particular session, we are going to use the Intel. So we will use the vanilla flavor of the TensorFlow and see how the stable diffusion works. And then we use the Intel optimizations for TensorFlow and see what is the performance gains you get out of these things. So along with this thing, we have like the Intel distribution for Modin, which is actually a replacement for Pandas. And some of our customers have seen multi-x improvement in performance when they replace Pandas with the Modin. And the advantage or the beauty of all these things is, basically, with one or two lines of code changes, you can actually have this optimizations implemented in your solutions and get improvements in your performance multi-x. Especially on the Pandas with Modin, or the SkyPy, or even for the PyTorch and other things, there are optimizations specifically implemented that targets using, say, for example, if you replace Pandas with Modin in your code with two lines of code change, What it does is pandas is generally runs even though you might have say 20 cores on your CPU, pandas generally runs on only one core. What Modin does is Modin, if you use the Intel distribution of Modin with two lines of code change, what it does, it's going to actually use all the 20 cores in your machine, in your CPU that you might have, and you get like a multi-x improvement in the performance. And similar use cases for Intel optimization for TensorFlow or the Intel optimization for the PyTorch. You might be using a vanilla flavor of the TensorFlow or the vanilla flavor of the PyTorch. We recommend using the Intel optimization for the PyTorch on top of that with just few lines of code change, and gain benefits of some of the accelerators that might be within your CPU, right? Say for example, the latest 4th gen Intel Xeon processor has an AI accelerator called Advanced Matrix Extension (AMX). Basically, what it does, it's actually computes all this various matrix multiplication that's part of this AI journey into a much more efficient way. So we encourage you to use all this kind of optimizations and toolkits that are available. There's the link here is flashed software.intel.com/oneAPI. Go here, start, and it's all open source and free to use. Go ahead and use it, and it's available in various forms. It's available as an Intel installer or as a Docker container, or with the Linux installers like apt or m, or the with the conda. Intel also has a cloud specifically called Intel Dev Cloud. It's meant for not for the general public. It's meant only for developers like you and me, where you can actually work on the latest Intel hardware for free. Some of the instances are available for free. We encourage you to sign up with Intel Developer Cloud, and I'll show you as part of this demo where you can actually sign up with the Intel Developer Cloud, spin up an instance and run your AI workloads on that. You can actually test your AI workloads on that and deploy it and test it with all the latest hardware. Both the CPU and GPUs are available. Use that. It's all available for you as for free for 20 days, and then you can keep extending it if you're continuously using it, right? And that's a pretty good options available for you as a developer. So do make utilizations of that. And before I jump into other slide, let me see if there are any questions. Okay, I don't have any questions. Let me continue, keep going. Maybe at the end we can stop for the queries. And now let's talk about stable diffusion. Many might be already be aware of what is stable diffusion, but for those who don't know what stable diffusion is one of the open source generative AI model. Specifically, it takes a text prompt and it processes the text prompt and can generate an image for you. Here, as an example, I'm giving like say a photo of an astronaut riding a horse on Mars. I give this text prompt and it processes that this thing and spits out an image for you, right? And this is an image that never existed, and it actually created out of the training it had. But if you actually see from an perspective of there's another option also for stable diffusion, like you not only can give prompts, you can actually also give an image and a prompt, and then ask you to generate a totally new image. Here I'm actually giving an image of a person running in the woods, and then also giving a zombie running through the woods as a prompt. It spits out an image with a zombie, totally brand new image for that. But this is for from a perspective of an end user perspective or a non-technical person perspective. These are the options available, but we as developers, we are more interested on the technical aspect. What are the internal things that happens internally within the stable diffusion to do all this magic, right? If you see, stable diffusion inside has two major components. One is a text encoder, another one is called a image generator. So what this text encoder does is basically it takes your text prompt, a zombie running through the woods as a text prompt, and it actually converts that into a numerical representation called tokens. Right? It's called a vector token. Basically, it's a matrix of numbers that represents the prompt that you have given, and it takes that token and gives it to the image generator for you. And what the image generator internally further has is two different components. It's called the image information creator and the image decoder. What image information creator does is it takes the token from the text encoder, and it actually iterates through multiple steps. At each step, it actually generates a new image. It actually begins with an image with full of noise, and then it actually takes that, iterates through the prompt and see what's an image it can actually generate. Like, if you, one of the configuration parameters when you actually are dealing with stable diffusion is the number of steps. Usually you can give 10 to any a number between 10 to 50 steps is a good number. Based on the kind of accuracy that you need, you can actually play around with those numbers for a specific use case that you're dealing with. So it iterates through that, the process, and finally it generates an high quality kind of intermediate token that it actually gives to the image decoder. And the image decoder takes that token from the image information creator, and basically it generates the final image for you. So if you see, internally, stable diffusion is actually a combination of three different models. There's an text encoder. It's the text encoder model is a clip text. It's again an open source model that is being used. And then there is, for the image information creator, there's a unit and scheduler model that actually iterates through all the different steps for the token that it receives from the text encoder, and generates an tensor that is being passed to the image decoder. And finally the image decoder generates you these things. So with it, this is covering a very high level. This is again, we haven't gone into the in-depths, considering the time limit that we have for this session. What I will encourage is, with this basic knowledge, you can go ahead and explore more of this. And while encourage you all to always try to get into in depth of things, don't just try to see how you can use a model or how you can use a particular tool. All you as developer, you and me as developers, actually need to actually get into the internal details of it, specifically for the generative AI. uh, Generative AI works, say for example, the prompts, right? If I give a prompt, say for example, a zombie running through the woods, if I, as a engineer, if I know all the internal details, how it's actually working, I can actually give better prompts. I can know how the internally how it works. Then probably I can give a better prompt for it to work, give you better results, right? So that is one use case, one thing that helps you, but also it helps you in understanding what are the internal details, how you can optimize things and all the things. So encourage you to do spend time, attend workshops, go through. There are tons of YouTube videos explaining you the internal details of how a stable diffusion works, or maybe llama 2 model works, or try to play around with it. There are many options for you. There's an Intel Developer Cloud. There are collabs from Google and other things. There are many resources. We are all living in a very lucky time where all these resources, many of the resources are available for free, and it's only your interest and your passion is the limit for you. So use those opportunities, advance your knowledge, and do share those knowledge to others as well, and be relevant in the industry. So with that, we'll actually go with a short demo on how to optimize the stable diffusion model that is using TensorFlow. And like, I'll run the stable diffusion model with TensorFlow, and then I will use the Intel extension for TensorFlow, and see how the there's a performance difference between these two different software stack running on the same hardware thing. You could run this on the Intel Developer Cloud. I strongly encourage you to all sign up with the Developer Cloud, or you could also alternatively also run on the Google Cloud C3 instances that are available. But again, it's a paid thing. You might have to pay for to use those instances. To begin with, maybe you can use the Intel Developer Cloud. Intel Developer Cloud is available here. Just search cloud.intel.com and do sign up. Like, cloud.intel.com takes you to this page. Click on the getting started, or getting started, and do sign up. And once you sign up, you actually will end up into this page where you'll be given a list of instances that you could use. uh, the second set of the first and the uh, this thing. The fourth one and the tiny are available for free for you to use. These are batch processing instances that are available for you to use. Just click on that and click launch instance, and it will take couple of minutes, say 1 or 2 minutes for the instance to launch. Once the instance is launched, you will see that instance in the view instances tab. So I have already set it up, and just going through some authentication, but it's pretty easy to set up. I'll also share this URL. This is the thing that I'm using. I'll put it up in the chat window. I don't know whether now probably somebody else can share this link. So I'm actually running through this example on the developer cloud machine, and this has complete details of how to sign up on the Intel developer cloud, how to use the Intel extension for TensorFlow, and then do all this experiment that we are going to do today. So like I said, go to cloud.intel.com, sign up, and once you land up here, launch this instance, and there is a short process on setting up an SSH access using public and private key. Go through that, and once you are done that, you can go and view instances tab, where you can see the instance that you are launched. And once the instance is launched, you can go ahead and launch the instance. And finally, using your terminal, you can connect to your instance. That's I'll show you how to connect to that instance. And once you are connected to the instance, initially when you connect to the instance, it actually takes you to the head node. You might see your user ID and some name with the head node at the last. Head node is something you land into, but you might actually need a compute node, and there's a short command. You run this command in the terminal, in the same terminal, and finally what it does is it will take you to a compute node. So ensure that you are in a compute node before you do start doing your experiments, right? Once you are in a compute node, clone this GitHub repository, and then cd into that directory. And once you cd into the directory, you run this command source prepare env.sh. What it does is basically it will create an conda environment and install all the software packages that are required. And all the once the packages are installed, and it will also run the Jupyter notebook. So you have this Jupyter notebook running on that machine, and you might have to do an SSH tunneling for that to access that Jupyter notebook on your local machine. So this again open up a new command line uh, window, and run this command, and you should have the SSH tunneling setup. Once the tunneling is set up, you can go to your browser and open that Jupyter notebook. So I have this set up here, and have the notebook open. And once it is open, it's pretty easy. I think most of you might be aware of what Jupyter notebooks are. But let's before that, let me show my thing, right? So I already logged into that machine. I have executed all the steps that was mentioned in that mentioned in this GitHub repo. Go through that. It's pretty easy thing. If you have at any point of time, if you have any issues, there's also a Discord channel available. You can join our Discord channel, where we will be able to help you on that. Or you can you have my Twitter link and LinkedIn link. Post me queries there. Probably I'll help you. I'll redirect you to the correct forum where you could post all these queries, right? So go through this 9 steps. So you should be after the end of this 9 steps, you land into this Jupyter notebook page, where your Jupyter instance is running. So I have this compute node with the Jupyter server running, and then there is a one more tab where the SSH tunneling is being run. So I ran that command, like SSH -l. I gave a local port, and then the IP address of that machine, and gave my credentials, and basically it's tunneling all that request from that server to my local laptop. So once this is successful, you should be able to see your Jupyter notebook, and you'll have this two notebooks, CPU and XPU. XPU will be for running it on the Intel Max series of GPU. So if you select this instance, it has both the Intel 4th Gen Xeon processor as well as the Max series GPU, right? So you could run your solutions either on the GPU or on the CPU. For this particular session, I'm actually going to use the CPU notebook. The only change between these two are just two lines of code change, and there's not much difference in the code. Just one or two lines of code change to ensure that it runs on the CPU. But again, like, and this uses the oneAPI standards, so you should be able to run it on any kind of a hardware, CPU, GPU, or even a computing hardware, or maybe your FPGA or any other things, or an accelerators you might have. And I opened that CPU notebook. Once I open this notebook, I have this notebook here. I'm going to install Keras CV, this particular version. Don't install the latest version for this particular thing. Yes, since you are also creating a Conta environment, just install this particular version, 0.6.1 as the version that is required for this particular lab. Use this, set it up. It takes a couple of minutes for you to install all the dependency and the Keras. And once that is installed, I'm going to set up certain environment level variables regarding the log levels and number of threads that I like to use and other things. And I'll start importing certain standard libraries, specifically from the Keras CB. I'm going to use the Keras CB models.stable diffusion and other libraries, that is Pro library and other libraries that I'm going to use. I'll import it. If all goes fine, you see this kind of message. You will not encounter. If you don't run this first one, probably you might encounter an error, but that's okay. It's a trial and error method that you want to do. Try it out, and you should be able to get it up and running. And the Intel Developer Cloud already has the oneAPI already installed. You don't have to specifically install the Intel extension for TensorFlow. It's already there for your machine. You don't have to specifically do anything additional. Also, if you are running CPU, ensure you are using this kernel, ITEX CPU. If you are running GPU, ensure you are using the ITEX XPU kernel. I know there might this actually we are getting too much into technical things. Some of you might not be able to catch up with some of the things, but that's okay. The idea here is to share knowledge and on the high level and understand what are the different options available for you as a developer, and then come to the Discord or supports channel to get further help from when you actually try it out to yourself, right? So don't worry about that. If you're not able to catch up with some things, like if you don't know what is Jupyter Notebook, or if you are finally finding any issues, we can definitely we are there to help you later. I'll share you the Discord channel. Come back to the Discord channel, and we can help you there. And then I'm actually defining a short method to draw a image, basically comparing the performances. That's not of relevance for this particular demo. What is relevant starts from here, where I'm actually trying to configure the stable diffusion model with the vanilla flavor of the stable TensorFlow, right? So I'm giving number of iterations as one, and that I'm using the TensorFlow XLA compiler. I'm setting it to false, and the data type precision that I'm using is 14.32. P32 is the precision that I'm going to use. And you'll see for the Intel extension for TensorFlow, we will be using a different data type that we'll talk about when we get there. I'm using a batch size of 1. And if you remember in the slide I showed you, the image creator has goes through iterates through a number of steps. It takes the token from the text encoder, iterates through the step. So here I'm giving the steps as the 50, and then there is something called seed value. Seed is basically if all the other parameters and seed value is same, for a given prompt always generates the same image. But if you want for a given prompt the stable diffusion to generate different images, try to give a different seed value, so you end up with a different images. Probably later, if I have time, I can show you that demo also. I set up these parameters, and then I set up the stable diffusion model. And once this model is set up, and I give a prompt. A prompt is a photo of an astronaut riding a horse on Mars, and I'll do a warm-up session so that when we are actually comparing the results, it's better to do a warm-up session so that all the caching, memory, everything is loaded properly, and we don't account for those loading times into in our final calculations. So I do a warm-up session, and then I do the actual inference. And if you see here, without any optimizations, internal optimizations, with the warm-up session, it took around 141 seconds, and running an inference, it took around 127 seconds, right? With FP floating point 32 as the precision, right? And it generated an image. This is the image it generated. It's pretty nice. For a 50 step, it's almost nice. There's some discrepancy here in the lag and also, but that's okay. It's only thing probably you might have to improve your prompts. The better you improve the prompts, the better is your results. And now what we do is, now we'll go and use the Intel extension for TensorFlow. That is, we import that Intel extension for TensorFlow. On the developer cloud, if you are using the Intel Dev Cloud, this is already installed. You have to just import it. You just write this one line of code, and it's already there. But if you are using GCP C3 or any of your local machines, probably you'll have to install the Intel oneAPI extensions, Intel installers. You could use that. There's also one more way you could do that. I'll share this link to you. Use this link if you have, based on these things, like say for example, I'm doing an inference optimization. Select inference optimization, suggest what all tools to use. Say for example, it's suggesting you to use TensorFlow and PyTorch, and you could go ahead and download the offline installer directly. Or if you need any additional things, you could you download those things, download it. I'll share this link here in the chat. Please do share it in the for the audience. Use this configurator. Yeah. And configurator will allow you to download those packages for your local machine. If you're using developer code, don't worry about those things, and just go ahead and import that. And I have imported the Intel extension for TensorFlow, and I'm actually setting up certain options. I'm basically using the bfloat 16 as the data type precision. And also setting up the auto mixed precision options, right? What it does is, Intel Xeon 4th gen processor, the Sapphire Rapid processor, has an AI accelerator called Advanced Matrix Extension (AMX). And what it does is, it will actually enhance the certain computations that are specifically required for this AI workloads. And we are basically using bfloat 16 data type all and enabling those extensions. With that, we should be able to see an improvement in your inferencing time. I'll enable that with this simple changes, five or 10 lines of code change, and then I set up the configuration and rerun the same thing. I'm just again taking up the model, the same stable diffusion model, do a warm up, and do the inferencing. Now, when I do that, if you see it actually for the warm up, it took around around 88 seconds. And for the image generation using the bfloat 16, it took around 91 seconds, right? When you actually compare this with the result, and the image is almost same, there is no change in the image finally it is generated. Both the optimized version and the vanilla flavor generates the same kind of image. And if you see, it's all running the same thing, and it gives you pretty good performance improvement. It's almost like there's 30% or close to 30% improvement in your performance time. And if I plot it, you could see a difference, right? With the FP32 and vanilla flavor of this thing, and with the Intel extension for TensorFlow, you will get pretty good optimizations. So this actually ends the demo. So go through all these things. Encourage you to go to one API or use the AI configurator link that I gave you. Go here, download these things. Use the optimized version. Don't just use the normal version of PyTorch or TensorFlow. Use the optimized versions of this TensorFlow and PyTorch or all the other libraries that I discussed earlier. And also encourage you to sign up with the developer cloud. This is specifically meant for developers like you. Use this for your advantage, gain more knowledge on all these things, and be an expert, improve your skills on these things. So with that, probably I can come to a conclusion. Yeah, you have seen the performance improvements, and that's actually ends this demo. If we have any specific questions, probably I'm open to the questions now. Meanwhile, if you are interested in stable diffusion or other things, there are a lot of other tools also. There's something called Invoke AI. Google up Invoke AI, GitHub, land into this page where this is again an open source front end user interface for you to use stable diffusion. It gives you a nice front end where you can give the prompt and set up all the parameters and run it locally or run it even on your dev cloud machines or cloud machines, right? Use this. There are a lot of other libraries, additions to stable diffusion. So encourage you to all explore all those things and take benefits of this open source software stack. So with that, I am open for questions.
Yeah, Anish, there are a number of questions from the audience.
Sure.
Uh, so let's start with Kumar Shivan. So Kumar Shivan is asking, is a stable diffusion different from GAN?
Yes, stable diffusion. I mean, finally, they all actually serve the same purpose. But stable diffusion, the technique it uses is a diffusion technique, where it actually you breaks up a noisy image and slowly generates the final outcome. So we don't have to worry about that whether it's a GAN model or some other thing. These are all different types of ways to approach a solution. You should be as developers probably need to be aware of all these things. Good, that's a pretty good question. So yeah.
Cool. Before moving to the next question, Anish, can you check your camera? I guess you're not visible to anyone here.
uh, okay, sorry about that. Let me check. I'm not sure, there might be some setting issues. Let me check.
We can drop it. Like if it's causing an issue, we will just continue.
Okay, I think there's some issues with the camera.
Cool, cool. No worries. Let's move to the next question.
Yeah.
So next question is from Adarsh. So Adarsh is asking, you see the image you gave and the image generated by AI is a more of an animated one. So how can we make it more realistic?
uh, okay, is my screen still visible? Yes, I
Mm,
think should be visible. Let me see if I can quickly run.
yeah, your screen is visible.
So just give me a moment. I'll quickly run the Invoke AI on my machine and show you some of the images that looks very real, right? I mean, it's um, not only kind of looks animated, but again, it's all depends on the prompt that you give. See, Actually, I tried to generate. While I set up this, just what I'm trying to do is I have set up all the dev cloud. I'm trying to log into my machine. It takes a couple of seconds to log in, and if you see, I'm in the head node, and then I'll switch to the compute node. I'll run this command. It takes me to the compute node, and then I have the invoke AI here, and I'll run. Let me start the invoke AI. Before I start the invoke AI, let me take the IP address of this machine. The IP address of this machine is 24, and then I will start the invoke AI. Again, all these commands are available in the invoke AI GitHub link. Now go to that. You should be able to get all these things, and it takes a couple of seconds for it to run. Um, so and once it runs, I'll show you the kind of images it actually generates. Right? It actually generates a very good images that are looks very realistic. Right? Or you can actually also Google up in the interest of time. Probably we can just the openly available. Things. So you just search like stable diffusion prompts. Mm, and all these images are actually generated by stable diffusion. I mean, some of them looks animated. Again, it's all based on the prompt that you are giving, right? Like a pop art painting. If your prompt is like that, you might get something similar to a painting. But you also get a very realistic things. Let me quickly see if I can pull out some. Yeah, this also looks very realistic. The prompt is like a portrait photo of an Asian old. Okay, yeah, these are like this actually looks very realistic. It's actually comes very close to. Yeah, real. Definitely, prompts, stable diffusion, or all the other open source models can generate images that are very realistic. It looks real. Not only can generate images that looks like an animation or animated thing, but it can also generate an beautiful image that are very realistic. So do explore that. Again, it's like I have couple of prompt examples here, right? There are a lot of prompt examples, like say a high fashion photography portrait photo of a Swiss female model with blue red hairs. Just give try to this again is all you need to play around with the different prompts that you based on the prompt that you are giving. It actually generates a different images for you. So to answer to your question, stable diffusion or any other models like the OpenGenie not only can generate images that looks like animated, but it can also generate images that looks very realistic, and you might not be able to differentiate between the stable diffusion generated model and others.
Cool. I guess that
Okay.
solves it for the Adarsh. Anish, there's another question from Tech Society Triple ID Bhubaneswar.
Hmm.
How can one effectively understand and interpret the outcomes of a generic algorithm in the context of solving complex organ optimization problem?
So is it did he mean genetic algorithm or generic?
Genetic.
Genetic.
Yeah.
I'm not sure if he actually meant genetic, but if you are meaning to use generative AI for some kind of a molecular research or genetic research, definitely you could use that. And there are a lot of research organizations and enterprises already started using it. And definitely you could use it. But again, you need an expertise. You might not be able to straight away use a models that are open source available. Take that open source model. Say, for example, you could take a Llama 2 model and take the Llama 2 model, and then probably you need to fine tune it. What I will recommend is, if you are targeting for a specific use case like genetic engineering, genetic research, or say banking and finance, or insurance, or manufacturing or healthcare, take a Llama 2 model, say 3 billion parameter model or a 7 billion parameter model. Probably 3 billion parameter model should be good enough. Take those smaller models, fine tune that model to the custom data set that is specific for the industry that you are trying to target, right? So you as an a researcher working on genetic engineering or specific things, you might have a lot of data set with you. Say for example, Intel is working on silicon manufacturing all these various silicon hardwares like the CPU, GPUs, and accelerators. So over these years, Intel definitely will have a lot of this data sets. Intel can take those data available within the enterprise and can fine tune some of the large language models, and basically help in further research, or help in increasing the productivity of the engineers. This is just an example, and I didn't mean that we are doing that, but I'm just giving an example of what's the possibilities. So don't go. Also, one thing probably you might have to note here is, don't go with the hype that you might have to use an 100 billion parameter or a 1 trillion parameter model for your enterprise use case. Just have this thing in your mind. Say, for example, in the ChatGPT, open ChatGPT came up, and it was using the ChatGPT GPT-3 model. It was 176 billion parameter model, and that 176 billion parameter had data from the beginning of human history, from the written history to till the date it was trained. So the entire human history could become can be loaded into a 176 billion parameter model. And if you are have a company like say 100 years old company, even if you are 100 or 200 years old company, the amount of data that you might be generated can be fit into few million parameter, or at most 1 billion parameter thing. So take up a 3 billion parameter open source model like Llama 2, and then use the data that you might have, and fine tune it. Don't go with the craze that you might need an 500 billion parameter model or 1 trillion parameter model for your enterprise use case. If it's a generic customer use case, the end user use cases like chat gpt or something, definitely you might need a bigger model. But for most enterprise, so for almost all enterprise use case, you can begin with a smaller model, like the genetic. If you're doing a genetic engineering research, take all the data set that you might have genetic engineering. It might hardly fit into few million parameters, right? It will not even go into a billion parameters. Take that and fine tune that with the open source model, implement all the guardrails, and you should have a pretty good model that actually can cater to your needs.
Hmm. We have last two questions, Anish. One is from Avinash Mishra. If stable diffusion creates an image from a complete noise, then what happens to the input image? How is the given image correlated with the noise that it creates?
So, stable diffusion has two ways, like I said, that has two different approaches to generate an final outcome image, right? It can actually take just take the text prompt, and then it generates kind of an noisy image, and from that noisy image, it tries to decode into an actual image that you might be seeing. Or the other way is, you might have to give an starting image, like the demo I showed you. I might give an image of a person running, and what it does, it takes the it knows that from the prompt that it might have to take only that person as the this thing, and maybe like the person is running. So it will take that person's characteristics, whatever the characteristics in there in their input image, and will finally try to blend that into the image that it is generating. So, to answer to the question, it's basically it will take certain inspirations from the input image that you have given, and finally it combines with the final image, the final image encoder decoder component you saw, the third component that you saw in the internal working of the stable diffusion. It actually merges that into give you the final outcome.
Okay. Next question is from Kumar Shubham. Hi, can you give me an insight how DALI works? Is it the same you discussed or different?
Dali is also very similar. This thing, I mean, Dali is also a model that gives you similar things, right? Basically, you give text prompts, it can generate an image for you. Um, Dali, I think it works on a different. Internally, the working is slightly different for Dali. I don't know the exact details, but it's slightly different from how Stable Diffusion works.
Cool. Another question from him only. How do we guarantee safety and privacy while creating with such types of images?
Okay, these generative AI models per se will not give you the safety and guarantee safety or privacy things. In fact, all these generative AI models can be prone to privacy issues or safety issues. So, you as an enterprise, like I gave the example of the financial institutions, they not only fine tune the model, but they also have you. One of the things that you have to do is basically implement the guardrails, right? Intel has certain tools and technologies to do that. If you can actually Google responsible AI, there are things for that. There are guidelines on how to have a very responsible AI in terms of ensuring the privacy and security things are taken care of. There are multiple approaches. You might have to implement those approaches in your pipeline to ensure the security and the safety and privacy concerns are taken care of. There's also a tool called a deep fake catcher. So Intel has a tool called deepfake catcher. It can actually detect the images that are actually generated by AI. It can differentiate images generated by AI from the realistic images. So there are multiple tools like this available in the market. So based on the specific use case and domain that you are working on, you might have to implement those guardrails. That is a pretty critical part of this entire pipeline. It's not only developing the solutions, but implementing guardrail. That's a very good question. I think you should be doing all those things. There are multiple ways to do that.
Cool. Man. There's another question. There are two. I guess it's with the in response to the query you solved. Avinash Mishra is saying that we can use LLAM A2 7B chat HF for end use cases as well.
We can use Llama to 7 billion chat Hugging Face model for end use cases. Yes, you need to apply for a license. It's actually Llama 2 model is from Facebook. You need to apply for that license. Once Facebook gives you that license, I'll say, read through the terms and conditions of the license and see if it actually meets with your corporate guidelines. If it's meeting, go ahead and use it. Uh, for most of your generic evaluation, this shouldn't be an issue. I have applied for it. They have granted to me, and we are internally. I'm also internally evaluating it. So you should not have any problem for end use case. But again, I'm not the legal expert on that. There are legal private things. Facebook has its own legal this thing for using how you can use Llama. Talk to a legal expert. They might be able to help you based on your internal corporate policy.
Great, great.